So if we have an ionic compound, that was my Chem 11E and that was last. The key thing is going to be to balance your charges. Okay? I will tell you, the biggest mistake that people make is not balancing their charges. We're on page 66. 66. And even with all these people, we're still missing a lot of people. Wow, crazy. Okay, anyway. So basically, you're going to just find out what the ions are. Make sure that the total positive equals the total negative. So when we say balance the charges, that means that the total positive has to equal the total negative. So that's all there is to it. And there's a few little extra things like don't write Roman numerals in a formula. Okay? There's a few other little things like put brackets around your polyatomic ions if you have more than one. But other than that, that is the only thing you need to know. Balance your charges. Okay. So here we have, for example, sodium chloride. Okay, and I'm going to do it from scratch over here. We have sodium, which is Na, and if you look that up on your periodic table, sodium is over in column number 1, so its charge is plus 1. Chloride is on the far right, second from the right. Okay, it's in column number 17, so its charge is minus 1. And guess what? My positive charges are equal to my negative charges. So do I need anything else? No. So that just means I need 1 sodium and I need 1 chloride. So my formula is NaCl. Remember, if there is no subscript, that means there is 1 atom. Yeah, so we have 1 sodium and 1 chloride. Is good? Okay. Let's try potassium nitride. Potassium is in group 1, so just like sodium, it is plus 1. Let's go look up nitride. Nitrogen is in group 15, so it has a charge of minus 3. So we have N, 3 minus. So my total negative charge is 3 minus. How could I get a total positive charge of 3 minus? Each K is plus 1. How many Ks would I need?
This many.
I need 2 more, or 3 in total. Okay, so I would need K plus 1, K plus 1, K plus 1 equals 3 positive. Once I have that, I write a formula that says I have 3 Ks and 1 N. So that's going to be K. How do we show we have 3 Ks? Put the little subscript at the bottom, K3, and then an N. Iron 3 oxide. So if it is one of the multivalent metals, one of the red zone metals, you will always have a Roman numeral to tell you the charge, okay? Don't forget, though, that this tells you the charge. Sometimes people read this and they're like, oh, iron 3 oxide, Fe3O. That would be incorrect. It's the charge, not the number of atoms. So I don't want 3 irons. Okay, we don't want that. Remember, you're working on balancing your charges. So what is the charge of iron? It is 3 plus. Anyone know the charge of oxide? It is 2. Okay, it's in column 16, so it is 2 minus. So, oops, that should be Fe, 3 plus, O2 minus. Now, there's a couple of ways of doing this. One way is if you know how to do lowest common multiples, you can use that and you can say my lowest common multiple of 3 and 2 is 6. So I would need to have 2 Fe3 pluses to give me 6, and I would need to have 3 O2 minuses to give me 6, right? But if you prefer a sort of more concrete way of doing it, you can say, at this point, if I just have this here, I don't have enough negative charge right now, yeah? I have more positive than negative. So I'm going to add another oxygen. But now that gives me 4 negative. So now I have more negative than positive. So I'm going to add another positive. Whoops. I think my brain said positive and wrote a P. Fe3 plus. But that now gives me 6 positive. So now I have more positive than negative. I can add another negative. And I just go back and forth like that until, oh, look, that one's -6, until they are both equal. So that's the 2 ways of doing it when you have like something that's not just, oh, this one has to be twice as much. Okay? You can use the LCM, lowest common multiple, to get both of them to equal to 6. Or you can just add to whichever side needs more and go back and forth until the 2 sides are equal. Okay? Iron 3 oxide, blah, 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 blah. Okay, there's some exercises here. I'm actually going to skip ahead to 4.4b, which is on page 70. The only thing that's going to be different about this one is that we are going to look at how it works with polyatomic ions. So this would be using your green sheet. Yes? Yes. Yeah. So we're going to write the formula for each ion. Again, we're going to make sure that the positive and negative charges balance. We need to balance the charges. Okay? So let us just take a look. And at this point, it becomes critical that you read the name carefully, because another common mistake is someone will read nitrate, but they will write the formula for nitride. Or they'll read nitrate and give me nitrate. Or they'll read nitride and give me nitrate. Do you know what I mean? You have to pick the right one. And one thing that is really good to know is that all 8s and ites are on your green sheet. Okay? They're all All 8s and ites are polyatomic ions, so they're on the green sheet. Most of the time, if you have an ide, that's going to be an element. And where do you find your elements? Those would be on the periodic table. Where do we find the 8s and ites? 8s and ites. Green sheet. Where do we find the 8s and ites? Green sheet. Where do we find most of the ides? Periodic table. Where do we find most of the ides? Periodic table. Okay, so make sure you're looking for those when you're looking to find out who it is. There are 2 ides, though, that are on your green sheet. Okay? Those 2 ides are hydroxide, which is OH minus, and cyanide, which is CN minus. So if you go looking for hydroxide on your periodic table, you won't find it. If you go looking for cyanide on your periodic table, you won't find it. So if on your green sheet, let's just say we wanted to go here, you might say, I'm going to choose to highlight my hydroxide ion and my cyanide ion, just to remind myself that those are the only ides on that sheet. If you want to do that, that's great. You can do that. If you don't want to do that, that's also fine. You would want to do it both at the bottom, though, and at the top. Hydroxide and cyanide. Okay? Hydroxide and cyanide, those are the only ides that are polyatomic. Every other ide is just a one element. Okay, 4.4. There we go. Okay. We'll talk about brackets. If there are no brackets, how many of a polyatomic ion do you have? Just one. So if you have just one of a polyatomic ion, you are not going to use brackets if you have only one of a polyatomic ion. So let's say you have NaNO3. That tells me that there is one NO3 and there's no brackets. We do not put brackets and then have no number on the outside. Brackets must always have a number on the outside. Don't put brackets around a single element. Never. Cl2 is just Cl2. Okay? Not Cl bracket 2. But you do need to put brackets around if you have two or more of a polyatomic ion. You must have brackets. Yeah? And the reason for that is, let's say we had MgOH2 with the little bracket. That tells us we have two O's and two H's. So my thing for that would look like I would have Mg2 plus, and I would have an O and an H, and I would have an O and an H. That is bracket OH2. If I just had this one here, it would be MgOHH, and I would only have two H's and not two O's. Yeah? because this 2 only goes with that hydrogen because there's no brackets. So if there's 2 or more of a polyatomic ion, you need brackets. If there's only 1 of a polyatomic ion, do not put brackets. Brackets must always have a number on the outside. Okay, and now that we've gone through all of that, a few other things to watch out for. If you're given a name like sodium, hydrogen, carbonate, do you remember how when we were doing the naming, we were like, okay, you got your metal, and then you got the polyatomic ion. And there's always just how many ions? 2 different ions. So if we have sodium hydrogen carbonate, sodium is our positive ion. That means that hydrogen carbonate is all 1 negative ion. Okay? So you don't need to be like, oh my gosh, I have a sodium, and I have a hydrogen, and I have a carbonate, and that looks really confusing to me. I don't know what to do with that. Don't do it. What you're going to do is you're going to look on your green sheet and find hydrogen carbonate. Let's go look for it right now. So on your green sheet, whoops, went the wrong place. On your green sheet, those polyatomic ions, look under H. We have hydrogen carbonate, and it's all that one thing. Yeah? We have hydrogen sulfate. It's all that one thing. We have hydrogen sulfide. It's all that one thing. So if you see those, don't get freaked out by them. Okay? Couple other things while we're here. Look at this one here. We've got, actually, I'm going to do it down at the bottom. We have chromate and dichromate. People see that di and they want to give me 2 chromates, but dichromate is its own ion. So if you want to put a star beside dichromate so you don't miss it, you can do that. Okay, because often people will miss dichromate and they'll try and give me 2 chromates. Because di means 2, but not in this case. Well, it kind of does. So if I had sodium chromate, sodium is Na+, chromate is CrO4 2-. I would need to have 2 sodiums and a chromate, so that would be Na2CrO4, and that would be it. Yeah, that would be sodium chromate. But if I had sodium dichromate, it's not going to be NaCrO4 2. That is not sodium dichromate. Sodium dichromate will use the Cr2O7 ion. I think I've got an example for it later on, so let's just pop back there and see if I do. Okay. Oh, here we go. Look, dichromates is not 2 chromates. So if I had, ooh, here's a fun one. Let's do aluminum dichromate. What is the charge of aluminum? Look on your periodic table. Tell me what the charge of aluminum is. Aluminum is in group 13. And if we look, if you haven't written these on and you don't know that aluminum is +3, make sure you write those on for yourself, okay? Al is +3, gallium is +3, and indium is +3, okay? Zinc is +2, cadmium is +2. And silver is +1. So if you don't yet have those ones, make sure you've got them now. Okay? All right. So aluminum is 3 plus. Dichromate, we go look it up on our polyatomic ion table. It is Cr2O7, 2 minus. What do we have to do with our charges? Balance our charges. And I have a 3 and a 2. What is the lowest common multiple? Is 6. What would I have to multiply aluminum by to get 6? 2. And I would need to multiply dichromate by 3. So my formula is going to be Al2. And then I have Cr2O7, and I need to have 3 of them, so I need to put brackets around it. 3. Okay? Now, here's a little tricky one, and I have an ion, and it is named chlorate. And on your green sheet, it looks like this. I would like you to tell me, is this letter, this one right here, is that a 1? Is it an L? Or is it a capital I? And this is chlorate. Oh yeah, for sure. Yeah. Now I want you to think about this. If it is CiO3, what elements is it made of? Carbon, iodine, oxygen. If it is ClO3, what's it made of? Chlorine and oxygen. The name of this ion is chlorate. Which one is correct? Because it's made with chlorine. Yeah? Chlorine makes chlorate. Carbon and iodine don't make chlorate. Does that make sense? Because chlorate is based on chlorine. All right? So watch out for that because the font is not as beautiful as one might like. It is kind of hard to tell, but the I's will always be written. Let's go take a look at our data pages and look for, whoops, not there. Look at our green sheet. We have over here, can you see how this I for iodate has a bar on the top and on the bottom? Okay, it's got a line here and here. Capital I. Capital I is always going to have a bar on the top and on the bottom. But you have to look kind of close because the print's kind of small and it does kind of have like a little swoopy-dooey here. La, 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 la. But it's not a crossbar on the top and a crossbar on the bottom. So just watch out for that, okay? Okay. Let's try sodium acetate. Sodium is in column 1. What's its charge? +1. We have acetate. What does the 8 ending tell us? We should look on our green sheet. So let's go look on our green sheet for that. Actually, I'm going to bring this down so I don't have to keep going. There we go. Okay. So acetate is here, and it is CH3COO minus. When it just has a minus, does that mean -3? Does it mean -6? What does it mean? -1. Okay, so here we have CH3COO minus. Are our charges balanced? Yes, we have +1 over here and we have -1 over here, so we don't need to do anything. It just becomes NaCH3COO. Is good?
Okay.
Okay. Sure. Copper 2 acetate. Cu. How do we know the charge of Cu? It's in the red zone, so how do I know what its charge is? That right there is the charge. So it tells us that copper is 2+. Because it's in the red zone, it doesn't have a specified charge, but that Roman numeral will tell us its charge is 2+. Acetate, we just looked up, CH3COO minus. Are our charges balanced? No. What do we need? We need another acetate. So now we have 2 acetates. We're going to have Cu, CH3, COO2. And I'm going to wait here for a moment and see if anyone wants to get mad at me for what I've written. I got 1 person, 2 people. What's wrong, Ananya? I need brackets around it because I don't just want 2 of the O's. I want 2 of everything. Okay? So watch out for that. Sometimes, you know, if there's no number there already, you'll forget the brackets. Okay? Lithium hydrogen carbonate. Oh my gosh. There's 3 names. Oh no, what do I do? Remember, this first one is going to be your positive ion, and the second one is going to be all the negative ion. Lithium is +1. Hydrogen carbonate, look under H. It's HCO3 minus. The charges are balanced. We're good to go. No brackets because there's only 1. Okay? Things I don't want to see. Chromium 3 carbonate. What's wrong with that? There are never any Roman numerals in formulas. Never, 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 never. Okay? And just watch out for ammonium because it is the only positive one. Very often people miss it. Where do you find ammonium on your green sheet? It's at the very tippy top, right up here. Okay? There's more examples, but I think you've got probably the hang of it. So you could work on pages, not that one. '67, '68, '69. And also '73, '74, '75. Quizzes 5 and 6, it's up to you whether you do them before you do the quiz 7 stuff. Or if you want to do this while it's fresh in your mind, you can work on this right now and then come back to quiz 5 and 6 afterwards, okay? Up to you in the order you do it in. Hi.
Did I ace quiz 7?
Let's take a look. I got stuff to get back here. I got...
You gave it.
Oh, I gave it back to you, but you've forgotten it. Okay, let's take a look. Davide. You got a 7? I did not get a 7.
Like, I got some wrong, but I don't know if it was 7 or 6.
6. 6, you got a 6.
Okay, then I'll just do 7.
Yeah, sounds good. I got quizzes for Paula. There you go. And Anushka. Yeah. So just things to watch out for, right? We've got the 8 there, we've got hydroxide there, but mostly it's okay. Okay. And why is it 3? Did I not mark this one? That should have been 4 out of 6.
Okay.
Okay, because lithium oxide was also good.
Okay.
Okay.
It's just Chem 11.
Doesn't matter. That's an old version of it. It's Science 9/Chem 11. If you have me for Chem 11, you will write these same quizzes again, but you won't remember them, so it's okay. But we do it really fast. We're like, okay, 3 days, boom, done, all of it, right? That was the next one.